Okay, working example number 2, determine the volume using different orientations. So an orientation is a position or view of an object. For example, turning an object on its side. So here we've got a couple of different drawings of a triangular prism. We've got an area of 20 for its base and a height of 10. And same deal here, area of 20 centimeters squared with a height of 10. So these actually have the same shape and size, but they're drawn in a different orientation. This one is laying on its side, this one is laying on its base. So it's just being conscious of what the base is and what the height is. That's the different thing that we're adding in here. So both boxes in this case, we've got 5 by 3 by 8, again 5 by 3 by 8. So both boxes are the same size, same measurements, but again they have different orientations. This one is laying on its base, and then in this one, well, this one's laying on its side, this one's laying on its end, and in this case we're actually changing its base. We're letting the base be whatever surface it's actually sitting on. So, question here, do the boxes have the same volume? If we look at it this way, the base on this one is 24 centimeters squared. The base on this one is 15 centimeters squared. So they've got different bases. This one has a height of 8. This one has a height of 5. So it may not be real obvious right up front whether or not they have the same volume. But if you look at their dimensions, 3, 5, and 8, 3, 5, and 8, that right there will give it away that yes, they do have the same volume. But let's have a look at it. Find the volume of each rectangular prism. So box A, area of the base was 24 centimeters squared. Its height, in this case, is going to be this distance of 5, which takes you between the two bases. So in this case it's 5 centimeters. 24 times 5 is 120. Centimeters squared times centimeters gives you centimeters cubed. So the volume for A is 120 centimeters cubed. Let's look at box B. Area of the base, in this case, we're being told is 15 centimeters squared. And its height, in this case, between the two base faces is 8 centimeters. So 15 times 8 is 120. Centimeters squared times centimeters gives you centimeters cubed. So in actual fact, they do have the same volume. So the boxes do have the same volume. Does the orientation affect the volume? No. No. The orientation of how you're visualizing the shapes does not impact the volume that the shape contains. Now, just a side note, going back here, since this illustrates it quite well. The area of this base we're being told is 24 centimeters. It's a rectangle though, right? The particular base for a rectangular prism. And the area of a rectangle we know is its length times its width. So in this case, 8 times 3, 8 centimeters times 3 centimeters. Well, 8 times 3 is 24. Centimeters times centimeters is centimeters squared. In this case, length and width are 3 and 5. 3 times 5 is 15, so that's where this area comes from. So on a rectangular prism, the volume can actually be calculated by multiplying the 3 dimensions together. But that's something that we'll save for the next section. All right, so there's another show you know. Please go ahead and do that.